Så, då börjar jag med att berätta lite om oss på Ariadne. Vi är ett ingenjörsföretag som hjälper er med att utnyttja det digitala underlaget för att få fram bättre produkter. Vi vill hjälpa er att jobba effektivare, öka konkurrenskraften och öka lönsamheten. Så om vi tittar på bilden nere till höger så har vi våra kompetensområden och vi utgår från den här digitala CAD-modellen i mitten och ju mer information vi har i den här 3D-modellen så blir jobbet mycket enklare och vi kan utnyttja den här informationen som idag till exempel till toleransanalys som vi kommer titta på mer idag och det självklart har man toleranserna på 2D-ritningen så funkar det absolut utmärkt också. Det tar lite längre tid så att här finns det tid att vinna och det kommer Felix visa lite senare. Våra affärsområdet är mjukvara och konsultuppdrag och utbildning. Vi är då PTC-återförsäljare som till exempel vi tittar på idag, Creo och Eztol som då är utvecklat av Sigmetrix faktiskt som då har verktyg för toleransanalys. Sen har vi Vidare som är model-based definition och automatisk kvalitetskontroll. Och så har vi Anark som är model-based enterprise och intelligent informationshantering. Konsultuppdrag gör vi det mesta så är det någonting ni vill ha hjälp med så får ni höra av er eller kika mer på hemsidan så har vi mer information där. Utbildning, vi är då licensierade partner med PTC så vill ni ha en PTC-utbildning så är vi de som kan hjälpa till med det. Resten av kurserna här har vi faktiskt utvecklat själva som vi är väldigt stolta över som grunderna i toleransanalys och formläge, FEM för konstruktörer och design för 3D-print och även där mer kurser finns på hemsidan eller så kontaktar ni er för mer information. Så då till dagens ämne, vad är toleransanalys? Ja, konstruktören han sitter ju i en perfekt värld men så ser ju inte världen ut eller ser inte ut efter tillverkning när man får detaljen i handen. Det finns alltid en variation efter tillverkning och sen när man monterar ihop alla de här detaljerna så blir det då en kedja av toleranser och när man adderar ihop alla de här så blir variationerna ganska stora i slutändan. Så få svaret på det här så gör vi då en analys och får fram vilka dimensioner som påverkar mer eller mindre. Vad vi ska tajta till och vad vi kan släppa på för att optimera toleranserna. Och varför ska man göra en toleransanalys? Ja, konstruktören han måste ju försäkra sig att det går ihop det han konstruerar och att det fungerar som det ska och det blir en robust konstruktion. Produktion, de vill ju veta om det går att tillverka och hur mycket kassering det blir till exempel. För det handlar ju om ekonomi till slut och det måste ju vara lönsamt det här. Och fördelarna då med en analys blir att man får svar på alla de här frågorna. Och det blir ju att man blir klar med projekten i tid och man vet att det fungerar. För det gäller ju att vara snabbare än sina konkurrenter, snabbare ut på marknaden. För det finns ju länder som har lägre kostnad för arbetskraft till exempel. Och vi måste jobba smartare och det är det vi är duktiga på. För man vill ju ha nöjda kunder och blir det billigare, ökar kvalitet och minskar support, då får man nöjda kunder. Så hur ser det ut idag och vilka toleranser krävs? Vi kan ju titta på konstruktörerna, han vill ju oftast ha snäva toleranser för han har gjort ett bra jobb. Man tar kanske i lite väl mycket och tillverkning, de vill släppa på toleranserna för att sänka produktionskostnaderna. Och den här balansfrågan för att få det helt optimalt, ja, då måste vi göra en analys för att få svar på alla de här frågorna, vart vi ska lägga oss någonstans. Och det är precis vad Felix ska visa oss nu, så det är dags för demo. Varsågod Felix.
All right, welcome everyone to this demonstration of Eztol. My name is Felix and I'm an application engineer here at Ariadne Engineering. So Eztol is a one-dimensional tolerance analysis program which is available for Creo as a plugin, but also as standalone software for Siemens NX, CATIA, and SolidWorks. And it has several advantages over a simple Excel stackup, which I will demonstrate today. So here we can see our model, which we'll work with. It's a small electric motor. And what we're going to analyze first is this little gap here where we fit in our washer between the bearing and the cover. And I want to make sure that this gap has the right size so we can fit in the washer without any problems. All right, I'll just simply start the Eztol tolerance analysis application and get right to it. I'll create a new stack up. What do I want to investigate? Well, it's the gap between the cover and the bearing. I can place some 3D annotations, and then I'll let Eztol do the work. It will look at the assembly constraints we defined in Creo, and it will look for the shortest path through all the parts to close the gap. So here we can see we go from the cover to the outer housing, to the cover on the other side, to the bearing, to the shaft, and then final to the bearing, which closes the loop. So if you already defined assembly constraints, we can reuse them and greatly speed up the analysis process. Then I'll just click OK. And on the right hand side here, have my stack up. The only thing left to do is give it a name. I'll just call it washer gap and put in the correct requirements. In this case, I want the gap to be between 2.5, 2.7 and 1.5 millimeters. And just like that, I've finished my analysis. Down here, we can see the worst case result. So in our case, with the current tolerances, our gap can vary between 1.12 and 2.92 millimeters. But how did we get there? Well, we see that up here. In this list, we have all the parts. As I hover over them, they get highlighted, which make up our tolerance chain. And then here in the middle, you can see all the individual tolerances in the stack up. How do we get these tolerances? Well, these specific tolerances I imported directly from my 3D model. So if I've defined 3D tolerances within my Creo model, I can reuse that information for my tolerance analysis. And that's another good advantage over an Excel stackup, that I can reuse a lot of the information I've already defined in my Creo model. It makes it much faster and easier. So we can see all these tolerances which has this chain link icon. Those I've imported, and as I hover over them, we can see that they get highlighted within Creo as well. And this is a bidirectional link. So if I would change one of them right here in Eztol, they'll also get changed within Creo. So I don't need to go back and change them manually again. No, this is a bidirectional link which works both ways. All right, but let's have a look at the result. So in this case, our worst case result down here, all the green part that's within my specified range of between 1.5 and 2.7 millimeters, and of course the red part that's outside where I don't meet the requirement. So in a worst case scenario, my gap can be slightly too large or too small. Additional information I get is a list of all the tolerances and how much they contribute to the result. And this can also be very useful in identifying tolerances which I might want to tighten to improve my result. But another good advantage is that I don't just get the worst case result, but also a statistical as well. So for example, I can conduct a root sum squared analysis, which is a simplified statistical analysis, or I can look at different statistical parameters, for example, capability. So now down here we have our real statistical result. You can see it in hand of the distribution. this case, I can put in the target quality. So to what kind of quality do I want to design my assembly? In this case, I'll put in 1.33, which is a very common target quality in, for example, the automotive industry. So I set in the target of 1.33. Then down here, I can see my distribution. So my expected maximum gap is about 2.54 millimeter. And then my expected minimum gap is about 1.49 millimeters. So slightly below our target. And you can see here my target quality 1.33 and my predicted resulting quality is slightly less. So I don't quite meet this target. So in this case, I can just tighten maybe one of the tolerances to improve my results slightly. Here, I'll just look at the contribution tab and I can see this linear dimension of plus minus 0.3 millimeter contributes the most to my result variation. So I go in, change that. Again, bidirectional link will automatically also change my 3D tolerance, 3D annotation, and I can see immediately how it affects my result. I get instant feedback, and now I can see I'm well above my target quality, and the predicted quality now is 1.6. And you can see the whole workflow is very easy and very quick, of course, if we have all those predefined information like assembly constraints or 3D tolerances. But of course, you can also do it without either. So let's define another requirement. In this case, I want to look at the air gap between the rotor and the stator and see how that can vary. Just define a new stack up. Select the outside diameter of the rotor, the inside diameter of the stator. Place my annotation again. And now you can see Eztol doesn't see any path through the assembly constraints I've defined because I disabled them. So now I can just define them manually. The first thing I want to do is tells Eztol which parts are involved in the stackup. And we can see the rotor is already transparent, so we'll start there. Then of course, we'll go to the shaft, through the bearing, to the cover on one side, to the outer housing, and we'll end with the stator. Afterwards, I'll just select the mating interfaces. So here I connect the rotor to the shaft, shaft to the bearing, bearing to the cover, and you can see, even manually selecting the loop, it's very easy and very intuitive and doesn't take much effort. And just like that, I've defined my stackup. So I'll click OK. Again, I want to, of course, give it a name. I'll just call it air gap. And my objective. So currently, I'm measuring axis to axis, but of course, I want to look at the gap. So I'll change that one. You can see now here in black, that's the gap. Nominal gap is 0.33 millimeters. And I want it to be, well, at least 0.2 millimeters. And just like that, again, I get my worst case result down here. You can see I also again imported a lot of the tolerances, but not all of them. So for example, wherever I don't have this chain link icon, Eztol just put in some default tolerances, which I can accept or change as I desire. For example, here, the outer diameter of the rotor, currently it says plus minus 0.05 millimeter. But maybe I want to put, for example, a plus minus tolerance here. So plus 0 and minus 27. And you can see our result again instantly updates. Then, for example, between the outer diameter of the rotor and the inner diameter of the rotor, I want a geometric tolerance, in this case, coaxiality. Let's put it to 0.1. If I want, I can select the material modifier, select my datum, and just like that, I've added a geometric tolerance to my stackup. So you can see again, it's very easy and intuitive, even if you don't import that information from your 3D model. And then down here, I can see my worst case result. Again, I'm slightly off. So currently the minimum gap is about 0.030. And additional, again, a great thing I get here, which I don't get from an Excel stackup, is this message here, which says calculated results are ignoring potentially significant 3D effects. What does that mean? Well, it means that in this case, it might not be a simple one-dimensional analysis. So due to how the model is built and the analysis is set up, there can be potentially some 2- or 3-dimensional effect, which have a large impact on the result. So in this case, for example, of course, the shaft is hanging not only on 1, but 2 bearings. And through that, the shaft can, of course, be angled, which will angle the rotor, which will affect the gap up here. So you'll immediately see that if an analysis is not just one-dimensional, but also maybe 2- or 3-dimensional. And then you can think about, do I need to include that in my analysis? Do I need to do some extra calculations? Do I maybe want to use another tool like Eztol to conduct a full 3-dimensional analysis? So again, something you can't get out of the simple Excel stackup, but it's something Eztol will provide to you. That gap. All right. So when you're finished, and maybe you want to share this information with your colleagues, you can create an automatic report. So in this case, I can take screenshots of the current environment for each stackup. And then one for the title screen. And I have this automatic reporting function right here. So I just click that one. The directory in where I want to save it. So it will look at the screenshots I took and then create an HTML document. So here I have my motor, one general picture. Then down here, all the stackers I created. So we can see the washer gap. That's OK. My target quality is 1.33, predicted 1.6. So we're good there. For my air gap, I had the worst case result. You can see we're slightly below that, so we get a red cross here. And again, we get this little exclamation mark, which says that there might be potential 3D effects. And then I get more detailed information on each stackup, the washer gap, list of all the tolerances, of course, and the result, list of the contributing tolerances, and the same for the air gap. So that's really good detailed information I can easily share now with my colleagues. And then when I'm done, of course, this information will be saved directly within your 3D model. So no extra documents. Whenever you share the model with your colleagues, they'll also have access to this analysis information. And another thing, since we're connected directly to the 3D model, whenever I change the design, do some updates, maybe change some dimensions, the analysis will of course also automatically be updated. So again, I don't need to go back to my Excel sheet and change those numbers. No, since I'm taking the information from the 3D model, I always have the most actual information. So that's now from my part. I hope you have enjoyed this demonstration on Eztol one-dimensional tolerance analysis for Creo, and I'll hand it back to Patrick for some additional information and for some questioning at the end.
Okej, tack så jättemycket Felix. Då ska vi ha lite information om de här grunderna i toleransanalys. Jag sa att vi hade utvecklat några kurser själva och den här har vi gjort själva för att få mer förståelse om toleransanalys, varför och hur man går tillväga och övningar, och så det här är en väldigt bra teoretisk kurs, en endagarskurs som då kan kombineras ihop med verktyget Eztol till exempel, så får man det bästa av två världar som man är på